Okay, we're in Unit 1, Lesson 11, and this lesson comes from Chapter 6, Section 2 out of the textbook. We're going to be looking at inverse functions and relations in this lesson. So our content standards for this lesson we're going to be looking, it says, for a function that models a relationship between two quantities, we'll interpret key features of graphs and tables in terms of the quantities, and we're going to sketch graphs showing key features given a verbal description of the relationship. And also we're going to be doing finding inverse functions. We'll solve an equation of the form f of x equals c for a simple function f that has an inverse and then write an expression for the inverse. And the mathematical practices that we'll be focusing on are to look for and make use of structure and look for and express regularity and repeated reasoning. So this all comes back to looking at patterns, following the same process over and over again, and then looking at the structure of the problem. So we've already transformed and solved equations for a specific variable. So what we're going to do in this lesson is find the inverse of a function or relation, and we're going to determine whether two functions or relations are inverses of each other. So our new vocabulary is the inverse relation and an inverse function, and we'll talk about what those mean in the lesson. And here's your concept for what an inverse relation is. Two relations are inverse relations if and only if, whenever one relation contains the element AB, the other relation contains the element BA. So if A is some relation and it has the point 1, 5, that means the opposite point 5, 1 has to be in B. Oh, look, it's right here. If 2, 6 is in A, then 6, 2 is in B. If 3, 7 is in A, then 7, 3 is in B. So basically, if an x value goes to some specific y value in one relation, then that same y value has to go back to the x value in the other relation. So our first example, we're going to be looking at finding inverse relations. It says the ordered pairs of the relation 1, 3, 6, 3, 6, 0, and 1, 0 are the coordinates of the vertices of a rectangle. Find the inverse of this relation and then describe the graph of the inverse. So pretty simply, in order to find the inverse of the relation, when they're just coordinate points, all you have to do is reverse the coordinates of the ordered pairs. So if we flip 1, 3, we get 3, 1. If we flip 6, 3, we get 3, 6, etc., etc. And then, so these are all the points in the inverse of the relation. Then when we graph it, I believe, let me go back to the previous slide real quick. First one had 1, 3 in it. 1, 3. Okay, so let me pull up my color toolbar. In green, this is the first relation right here in green. And then when we found the inverse of it, blue, up here, this one is the inverse. Mouse is skipping and I can't see myself right. Okay, so basically you'll notice here, if we had the point 1, 3, so 1, 3 right here, and that's on the first relation, that we're also going to have the point 3, 1 on the opposite relation. So if we go over 3, 1, 2, 3, and up 1, this is the point that mirrors that point on the inverse relation. And notice how when you do this, the two functions, the two relations, they are reflections over the graph of the line y equals x. So notice this point and this point, they're like opposite from this dotted line. This point and this point, they're opposite from the dotted line. This point and this point, they're both opposites. All right, so here's one for you guys to check your progress on. You've got a relation with ordered pairs, and then go ahead and find the inverse of the relation. Pause the video as long as you need, and when you're ready, go on and advance to the next slide. All right, so our answer for example 1, check your progress, is D. You're just flipping the coordinate points again. Okay, so here is the concept for inverses if you want to find the inverse of a function. basically the concept here, it says if f and f inverse, this is how you say inverse of a function, f to the negative, it looks like -1 power. Don't say -1 power, it just means f inverse. Then f of a equals b if and only if f inverse of b equals a. So essentially what's happening is you're flipping the a and b, which when we use stuff, we're flipping x and y. So if f of x is x minus 4, then we need to find the inverse. We're going to represent the inverse, f inverse of x as x plus 4. Okay, so f of 6 is 2. So that means 6 goes to 2. So we would need to find how 2 goes to 6. So right here, f inverse of 2 would be 6. Basically, you'd be plugging, here we plug the 6 in on the y side, and here we plug the 2 in on the x side. And this is a little bit confusing in this concept right here, but it'll be a little bit more obvious when we get to the actual examples of what we're going to do. Okay, so we need to find the inverse of f of x equals -1/2 x plus 1, and then we're going to graph the function and the inverse. So the first thing we're going to do is we're going to take the f of x and we're going to write y instead, because f of x just means y. So that becomes y equals -1/2 x plus 1. And then the second step is you switch x and y. So here we have y equals -1/2 x, and then we have x equals -1/2 y. You're just flipping the y and the x. And then step 3 always is going to be solving for y. So what we need to do here, let me put up my pen. We're going to subtract, actually first they multiplied each side by 2. So we're going to do this whole thing by -2, and then this thing times -2. So the left side becomes -2x, and then we're going to distribute this -2 over here. -2 times -1/2, that cancels to just 1, so we just have 1y. And then -2 times 1, that gives us the -2. And then we're going to add 2 to each side, so we're adding 2 here. And then we're going to add 2 also on the left side. These 2's cancel out, so we have y equals -2x plus 2, and so that is our inverse function. And the last step is you're just going to change the y back to say f inverse of x. So your inverse function right here is -2x plus 2, and remember the original function, f of x, was -1/2 x plus 1. So that's your inverse, and that's your original function, and then we're going to go ahead to the next page and graph the two functions. Okay, here's a graph of your two functions. The blue line is the original, and the green line is the inverse. And again, notice how these two lines, like this line segment right here, is symmetric and opposite this blue segment here, and this green segment here is opposite this blue segment here. Notice how they're the same distance away from the dotted line, y equals x, at every point along these two lines. Okay, so here's the one for you guys to check your progress on. You need to find the inverse of f of x equals 1/3 x plus 6. Then you're going to graph the function and the inverse. So pause the video as long as you need to find the inverse and graph it, and then go on to the next slide when you're ready. Okay, answer this time is C, and here's what the graph looks like for those two functions. Notice again, let's draw this imaginary dotted line through here, through y equals x. So and that wasn't perfect, but notice how you can still see they're symmetric around that line. All right, we're picking up, we're looking now at the key concept for inverse functions. So we've already looked at what an inverse relation is, and now we're going to look at what an inverse function is. So if you think about, if you can remember back to the last lesson, we talked about composition of functions in the previous lesson. and we talked about something called like f composition g of x, and we did g composition f of x. So the formal definition for what makes two things inverses of each other is that when you do f composition g of x, you just get the letter x, and when you do g composition f of x, you just get x as your answer, and you have to get x as your answer each time for both of these, and that's the only case when two functions are inverses of each other. So I know, as always, definitions are kind of confusing. Let's look at an example and see how this actually plays out. So we need to, example 3, we're going to verify that two functions are inverses, which means we're gonna show that they actually are inverses of each other. So this says that we need to determine whether f of x, which is 3/4 x minus 6, and g of x, which is 4/3 x plus 8, are inverse functions. And so like you saw on the previous slide, what we're going to do is we're going to do the composition f composition g and g composition f. So f composition g of x takes the g of x function, which is right here, and it plugs it in to f. So everywhere you see x in the f function, we're going to replace it with all of this stuff. So let me pull up my drawing toolbar. So originally, this is the f function right here, 3/4. This originally was just x up here. This x, when we came down here, it became all of this stuff, and that was your g function originally. So 3/4 times g minus 6, and g was 4/3 x plus 8. So when we do this, we're going to not simplify. We're going to be distributing 3/4. 3/4 times 4/3. You should be able to see that 3/3 cancels and 4/4 cancels. So 3/4 times 4/3 x is just going to give us x, and then we're going to do 3/4 of 8, which is 8 divided by 4. That's going to give us a 2, and 3 times 2 is this 6 right here. And then we have minus 6. And then simplifying, obviously 6 minus 6 is 0. So when we, right here, f composition g, we just get x. Then g composition f, we're going to take the f function, this stuff, and we're going to throw it into the g function. Over here, that's what we see. So this is our f function, and we're plugging it into the g function. So g is 4/3 x. All of this stuff right here, you're replacing the x with the entire f function. This is our f function. So g was 4/3 x plus 8. Now the same thing like we did over here for the f composition g, we're going to do for g composition f. So we have 4/3 times 3/4. Obviously that'll cancel again. We'll be left with just x. When we do 4/3 times negative 6, when we do 6/3, again that's 2. 4 times negative 2, that gives us this negative 8. Then we had a plus 8, negative 8 plus 8, obviously that cancels. And so g composition f is x. If you do both compositions and you get x each time, then it proves that the two functions are inverses of each other. All right, here's an example for you guys to try on your own. Pause the video as long as you need. When you have an answer, go and advance to the next slide. All right, our answer for this one is C. These are inverses of each other since both compositions equal x. If you want to see an example where things are not compositions of each other, ask me when you finished watching this video and I'll do an example up on the board of things that are not inverses of each other. Okay, so that's the end of this video. This is Unit 1, Lesson 11, Inverse Functions and Relations.